order of speakers that is in your program has been changed, so listen closely to hear who's going to be speaking on this panel, and in the excellent tradition established by Erica, I will introduce them all briefly, and then we will head off. Leading off, from Kibbutz Hatzerim in the south of Israel. He calls himself a farmer, but in fact he is a sophisticated agent and technologist from the multinational conglomerate and giant Nitafim, which has done so much to pioneer irrigation technologies. And not only that, hot off the press, just recently he was appointed to chair the international standard that is going to be set for wastewater reuse. So that's Nati Barak. Give him a hand. Our next speaker hails from El Quds University. Amr Mareh is a very a veteran hydrologist, water manager, expert. His present research has him looking at groundwater and hydrological situations in the Jordan Valley. He has a very, very diverse portfolio of research in the past, and we are so delighted he could join us here. Welcome, Amr. Next. Avner Ben Gosh, I regret to say, was once on the faculty of Ben Gurion University, and we lost him to the Nicholas School for the Environment at Duke University. And he is a well-known geohydrologist who has worked on the Jordan River. And I'm particularly interested if we might pull him on there in our question and answer, because recently his research has brought him into the area of fracking and the groundwater implications of that, and that's something I think a lot of us are thinking about. It's certainly salient for the region that I live in, and so we're very, very glad to have Avner on our panel as well. And then we are the local host and homeboy, David Zilberman from the economics department here, really a veteran researcher in the area of agricultural economics, has done so much work on the economics of drip irrigation, and then in other areas, for example, to try to monetize ecosystem services. And excellent to have him on the panel and have an economist, but we only have more than one economist because we also have Sharon Migdal, who's an economist, but is so much more, the director of the Water Resources Research Center at the University of Arizona. I've been there to Tucson and seen her incredibly talented, intelligent, and ambitious team that she leads. Has written on any number of subjects, and not only in academics, but also serves on more commissions and panels in the Southwest in Arizona than you can shake a stick at. So welcome, Sharon. So that's your team, and we're going to look. I'm told that the rules of the game are as follows. Everybody will open with about a 5-minute presentation and talk about whatever they intend to talk on this theme, and then we will have a few questions. I will ask, but mostly we're going to be looking from the audience, because as we've seen in our discussions, technology might be a game changer. Is it or isn't it? And if it is it changing for the better? These are the kinds of questions that we want to talk about here. So without me taking any more time, it's up to you, Nati.
Okay, hi, thanks. Miri called me. I think I was on my way from Tel Aviv to the Negev Desert one evening, and I got a phone call from Miri, and here I am. So thanks for everything. I'll fly through my presentation because I was planning on 20 minutes, and I have 5, so I will fly. Netafim started in the desert. I always say not because we were smart. We are not smart because we had no choice. High salinity in the soil, no water. We met the guy who invented drip irrigation. The rest is history. This is where we are today. We are the leading irrigation company in the world. We are working all over. We have global recognition. We are very much involved with UN agencies and Human Rights Council and so on. But I would like to talk more about our business. But by the way, last year we were awarded what for us is the most prestigious award, the Stockholm Industry Water Award. When I got this phone call in Swedish accent, I was almost positive that they invite me to receive the Nobel Prize. But no, this time it's no money, it's just recognition, but it is very important, and the Queen of Sweden is a very nice person. I'm not going to talk about the food challenges, everyone knows it. I'll say a little bit about water. Everyone is talking about water. Most of the water is going for agriculture, and in agriculture, irrigation is still 78, close to 80% flood irrigation, which is terrible. I not always wear nice pants. I usually go with jeans, and people don't know that one pair of jeans is consuming 4,100 liters of water in its life cycle, most of it in irrigating cotton. The other 40%, by the way, in laundry, and Levi's came with an excellent idea. They say, don't wash your pants so often, fold it, put it for 24 hours in the deep freezer, it will kill all the germs, and do it again. I'm serious. And I wanted to go to Levi's and say, listen, why don't you go to your growers and say, from now on, we buy cotton only from people that use drip irrigation. It will save the world. By the way, it will also save Nerafim. So this is flood irrigation. This is 80% of the irrigation on our planet. It's beautiful to watch, especially those pictures from Vietnam. It's terrible for the environment, and we would like to change it. Again, the issues, the challenges that we are talking about, when we are talking about agriculture, we are talking about the 4 F's: food, feed, fiber, and fuel. Some people add to it fun because they say that marijuana is also an agricultural product, certainly wine, but we don't care. I mean, we know that you get excellent results in growing marijuana with drip irrigation. People in Hawaii used to do it, go into the center of the pineapple fields, clear, plant marijuana and use the same irrigation system and get excellent results. Israel, again, you know, I can skip this because people are talking about it, Israel's solution to water scarcity. I'm going to concentrate on efficient usage of water through product, systems, and management. I'll say a word again. People were talking about the reuse of wastewater. You know, Israel is leading. Today, I think it's more than 80% of the sewage water that is retreated and used, and it should be used with drip irrigation because, again, as I said, I'm flying. This is the largest waterways treatment in Israel. The Shafdan, with 160 million cubic meters per year, are collected and delivered through a special grid to the southern part of Israel. In addition to the large one, we have some smaller facilities. This one is in a small agricultural community not far from where I live in Hatzarim. The picture with the camels, by the way, is in my kibbutz, in my farm. We are growing jojoba. You see the jojoba fields in the background. It's a nice crop because the camels do not eat jojoba plants. By the way, they used to eat, we used to manufacture in Israel cars, the Susita cars, which were made of fiberglass, and the reason that they stopped manufacturing it is because camels in Beersheba on the roads used to eat them. So we don't manufacture them anymore. So I flew, and I'll talk about the main topic, which is our technology, drip irrigation. You remember the pictures of the flood irrigation? This is drip irrigation. It's irrigating the plant, not the soil. And I personally love the picture on the top. This is a potato field in France. And you can see what we say, what we mean when we say irrigating the plant and not the soil. The soil is dry, it's aerated, and the nutrients and the water are reaching directly the roots of the plant. And we are talking about nutrition. It's not irrigation, it's not just delivering water, it's feeding the plant. But it's much more accurate and precise than the infusion that you get if you need some kind of infusion. It's much more accurate, and the technology is very unique. I'll talk about it in a minute. This is the very regular, very normal, the very basic drip irrigation system, an open field above the ground. This is corn in Turkey, and you see that one dripper line can irrigate two rows, and the plants are very happy, very healthy, very uniform field. This is subsurface drip irrigation for potatoes. And again, we're talking about food. I want to mention something. You know, when we started, we worked in the developed countries with the 2 minutes. With the more advanced farmers, now more and more we are going into your basic foods, developing countries, and our number one crop today is corn. This is the product. It's not just a hole in the pipe, it's very sophisticated. We have different systems. You know, we moved from, in order to measure the moisture in the ground, we have now meteorological stations, crop management technology. This is the future. This is what we call the family drip system, gravitation-based, developed specially for smallholders in the developing countries. And when we talk about greenhouses, which is the most advanced technology, it's not those greenhouses that we are talking about in West Holland or Israel or Russia. It is in Kenya, where small farmers are getting the same results as the most advanced farmers. Because if you do things right, if you put the right fertilizer and you irrigate on the right time, the plant doesn't know the difference. The plant doesn't know that you don't have a very sophisticated computer, and the results for those smallholders are exactly the same. I have to show this picture. This is Gaza. I have to show, I'll jump through all the good practices, and I'm telling you, you are missing. That's called, you know, when you have friends, you don't need protection. So, Israel Arava Desert is perhaps I mean, I was a young salesman in that region, and I didn't realize, I was just selling dripper lines and talking to farmers, and really, you know, out of the worst desert in Israel, we have turned it to the richest agricultural area in Israel. And again, it's not just us, it's partnership, government, NGO, the Jewish agency, which collected money in this part of the world and gave it, I'm talking about 40 years ago and something like this, and now 65% of Israel fresh produce export is coming from this region. India, again, a great project that we did with excellent results, water saving between 26 to 75%, same figures, increase in yield, and capacity building. We took a region of subsistence farmers and turned it into commercial agriculture. Kitui, this family drip system that we did with 200, the poorest of the poor, mainly women. I never knew that drip irrigation has a solution to gender issues. But then they told me that in Africa, when you're talking about poor farmers, you're talking about women. And instead of walking 8 hours every day to fetch water, they walk, even if we don't drill wells and so on, they walk only 3 hours, and it changes their lives. And so this is the impact. Afghanistan, people didn't like it because we took prime opium growing region and turned it into grapes and pomegranates. So not everyone liked it. And Afghanistan and so on, but I want to end with Wadi Atir. We were talking about the Bedouins. So there is a magnificent mayor in the town of Hura, and together with him we are doing this project of sustainable desert community for the Bedouins. And again, it's mainly women, herbs, traditional crops, traditional dairy products, and so on. And again, partnership between local NGOs, American NGOs, and the Israeli government, and of course the private sector. When I say private sector, it's not only us, it's other companies that are involved in this, and the West Bank, we're together with USA, we are doing a lot of work. So just, you know, to sum up, we are a business. We are a for-profit organization. If I'm forgetting it, and I'm forgetting it a lot now when I'm not in sales, my CEO is pulling me and saying, Martin, we are not an NGO, we are still interested in making some profit, but we are fortunate, you know, doing well by doing good. This is our business, this is the essence of our business. We used to say that our business is irrigation and our commitment is to sustainability, and today we say that our business is sustainability. By selling drip irrigation to the world, we are contributing to sustainability. Thank you very much.
Good afternoon. First of all, I would like to thank the organizing committee for inviting me to come here and present some of our results. Alone gave me 5 minutes to speak, but he did not mention in which language. If you want, I can speak in Arabic in 5 minutes, but in English it's not my This is things how going in the Middle East. Anyway, I will speak about technology and innovation changing political and environmental calculus in the area. And I want to mention why we need water technology. We need water technology to overcome the political constraints. As my colleague today mentioned, that there's a lot of constraints in the region, from transboundary, from the mountain aquifer, from many. There's everything is with. There is no what we call defined boundaries for the region, or between Palestine and Israel. So there is political constraint, and water is one of these constraints. And can overcome the economic constraint. We know that water pricing of water depends where you live, either in the northern or in the southern part of the West Bank, and the price is different from drinking purposes or for other purposes. And also, in order to decrease the tension between people, I mean that within the Palestinian community and between the Palestinian community and the Israelis. For example, if I compare the water consumption in northern part of West Bank to pass the moon for the people, it's about 26 to 30 liters per capita per day. I'm comparing to people in Ramallah, they consume about 60 liters per capita per day. And if we go to the north, to the south, to Hebron, they consume less than 30 liters per capita per day. And this makes people more tension against in the region. There's a tension that people say, okay, look, they consume more water and we consume less water. So this we have to overcome. Why the conflict about water continues? We know that there is a lot of many agreements about water, but the conflict about water is continuing until today. We have bilateral agreements, for example, the Oslo agreement that's organized how to deal with water and wastewater during the transition period. And this transition period is over since many years, and we don't know when this transition period comes to the end. And there is also joint water committee. The joint water committee, the function of this joint water committee is to facilitate water infrastructure, but nowadays or since many years, the joint water committee is one of the obstacles to implement water and wastewater infrastructure in the West Bank, because there is no equity between the Palestinian and the Israelis. The Israelis, they can give a veto for any project. For example, the Joint Water Committee needed about 10 years to give a permission to build a wastewater treatment plant in Nablus, west of Nablus. And until today, there is a negotiation since 1997 to build the wastewater plant in Turkey. So this is what we call it. We built a function, we built an organization that it hindered or obstacles to develop the water sector in the region. And we have also regional agreement, the Red Dead Agreement, and this Red Dead Agreement mostly between Jordan and Israel. But anyway, it's still not in function. And we have also multi-agreement like MITEC program, which is about waste salination of seawater, water database. We have the exact project. We have many projects, and still there is a lot of work done in this since 1993. But until today, there is conflict is continuing between both Palestinian and Israel. So we have to think about the tension source. The tension source is that there is no equity in producing and consuming water. My colleague Arontal mentioned that Mekerot supplied the Palestinian with about 54% of water consumption in the West Bank. It is correct, but on the other hand, they produce about 40 million cubic meter within the border of the West Bank and sell it for the Palestinian. So this is what we call it source of tension between both parties. The transboundary, I don't like this word because there is no boundary. In the reality, there is no boundary between the Palestinian and the Israelis. The boundary is only in our mind. This is the boundary that we think that there is a boundary, but in the reality, in the nature, there is no boundary. So this is the issue that about the mountain aquifer. For example, we consider it as transboundary, and Palestinians are in the upper stream, and Israel in the lower stream, and there is we share the resource. We until today or until yet, we did not think how to develop the resource, how to increase the volume of water. We say this is shared, this is Palestinian share, this is Israeli share, and until today we don't develop the resources. There is a trend for desalination. Desalination is trend, and the Israelis, they suggest that the Palestinians, they can buy water from the Israelis, but on the other hand, the Israelis said we have to get our water right and to produce or to develop our water resources, then we can decide if we can take the desalination water or not. The Israelis said to us, okay, take desalinated water, and this is what we call it inequity between the two parties, and it should change if we want to live together, I think. So for the Palestinian, we have to think in long-term solution. We have to think, not to think about that we want to drill a deep well in Israel, and we should wait, for example, 6 years until we get a permission from the Joint Water Committee, or we build 2 wells or 3 wells in Hebrew area to produce in the first 5 years a good amount of water, 5 million, and nowadays we don't produce 500,000 cubic of water because the recharge is limited and water is relatively old. So we have to think about mega projects like dams, Palestinian water carriers. For example, if the Israelis said to us, come, we give you water from the Jordan River, and we don't have the infrastructure to transfer this water, like the case in Jordan. So we have to think more than the mega project. Desalination plant and wastewater treatment plant. And this is the 4 mega project we have to think of. The precondition for success to give up the occupation. Give up the occupation. The occupation is a feeling that you cannot. I heard many lecturers they speak about management, but the question, if you don't control your resource, how you can manage it? And in our case, we don't control our resource. So to ask me to manage things that is control it is paradox. It's nonsense. So to give up the occupation, to share the resources and to increase the volume of available water. And these are the preconditions to have a successful. The one case, I will present one case study about Gaza Strip. All of us know the situation in Gaza. It's a small strip along the Mediterranean, and the high elevates. It is a crazy land. The water balance in Gaza Strip, for example, if you take it, it's about 90 million cubic meter groundwater abstraction for domestic supply, and 80% of groundwater abstraction for irrigation. And in this case, they produce about 170 million cubic meter total groundwater abstraction. It's about 55% deficit in the aquifer. And in this case, we work together with Israeli colleagues, and we defined the saline source, and I think Amir will present some of these results. So there is a deficit, water deficit on 150 million cubic meter water, resulting 3 times over exploitation of the aquifer. So the aquifer is depleted, and there is no source of water. In Gaza Strip, 95% of the consumption is based on groundwater resources until now. And 90% of the water produced in Gaza does not comply with the WHO concerning nitrate concentration and concerning also chloride concentration. The condition 2, that 1.6 million people are exposed to unacceptable water. The population growth is 3.5%, and domestic water demand is projected to grow 91 million cubic meter to 199 million cubic meter 2035. We don't know what will happen after that. But in this case, only about 5 million cubic meter is imported from Israel, and insignificant volume are currently produced by only 7 small waste desalination units, 6 brackish water and 1 sea water. This is the water demand forecast for Gaza Strip, and we can expect that domestic demand in 2012, 91 million cubic meter, and increase within the next 5 years to 180 million cubic meter, and the total demand is increasing. I will finish. The proposed source for covering the domestic water is the desalination. They project that in 2010, 0.4, and in 2012, 10 million. Nothing of this in 2014, and we don't have the 10 million cubic meter for desalination. This is the proposed strategy for the Gaza to recycle the wastewater and use it for injection to the aquifer, to use it for agriculture, for irrigation, increase the import from Israel to 5 times the current amount, plus the question, what's the price of the desalination water, and fill the remaining gap by seawater desalination. The technology cost, the total investment cost for is about 4,455 million, and this is for desalination unit and for power plant and for a carrier from the north to the south with the reservoir, and 35 million for non-revenue water program, 10 million for project implementation and consultant. This is the projection, and this is the Deir al-Balah proposed seawater treatment plant. There's also another suggestion about wastewater treatment, and this is the situation in North Gaza and Central and Gaza Central sewage projection and Khan Yunis and Rafah wastewater treatment plant, and none of this is now running, and perhaps you have heard on the radio and TV about flooding of wastewater in the last winter. And the current projection for active in the water sector, short-term, low-volume desalination unit. What's available now? Deir al-Balah is a small desalination unit. This is about 2,000 cubic meter per day, Khan Yunis, and this 6,000 cubic meter. But it's nothing to use it for the for the population in the region. But another desalination, what we call it, technology that we are using in the West Bank to use magnetized water or to magnetize brackish water and to use it in irrigation. And in this case, the USAID invest 6 pilot projects in the lower Jordan Valley. And that's all I try to talk about.
Good afternoon, everyone. First, I want to thank the organizers and Miri for having me here today. My name is Avner Bendosh. I'm a geochemist from Duke University. Before I was in Berkeley University. And I'd like to talk about, in my 5+ minutes, about science. You know, something that we are not much kind of using these days, and kind of bad word in some circles. So the point that I would like to make is that we have to see the big pictures, and we are trying to do it today, but we have to emphasize the science, and I would like to touch it with respect to water quality. So as you know, climate change is not into the future, it's already here, and many of the models that predict climate change predict that the arid zone is going to be more arid into the future. Northern Africa and the Middle East is part of that. So all the models, and here we see kind of agreement of the IBWC model, all agree that the Middle East is going to be into the future more arid than today, and we have heard that we're actually seeing those evidence. So in addition to water scarcity that we all talk about, there's issues of water quality. And the water quality are as important because when we have issues of salinization of water within Israel, the coastal aquifer, the mountain aquifer, we have issues in West Bank and the Gaza, and I'm going to show you following our presentation, and also Jordan have major issues of high natural occurring high radioactivity. All those elements of water quality is actually affecting the water availability in the Middle East. So this is a map of salinity in the coastal aquifer of Israel. Many of the water that are being used in Israel actually would not be allowed to use in California, for example, because they're exceeding the 250 milligrams per liter chloride. In Israel, a very liberal country, we changed the standards so we have more water to use. So similar, the mountain aquifer is surrounded by saline water, which affecting the ability to use the aquifer. I'm going to show this in a minute. And fossil water, we haven't mentioned this in the session before. The future of the Middle East is in the past with respect to water. These are vast groundwater resources in North Africa, Egypt, and Jordan. And Jordan, because of the severe water scarcity that was mentioned by Alon, is now built one of the largest water projects in Jordan, bringing water from the desert and bringing water from the DC aquifer by $1 billion kind of a project. They forgot one small thing, to measure the quality of the water. And what we did at Duke, we actually found that the very high level of natural occurring radioactivity in the fossil water. We found similar result in the Negev. This is a level that can pose risk for the population in Amman that is starting to use this water as a daily intake water for drinking. So there are many kind of issues. This is a diagram that's showing what would be the dose of radiation for the different population within Jordan. It's about 10 times more or even more than the World Health Organization permitted level for safety. So we're talking about a huge risk for a large population in Jordan, and the technical solution, which I'm focusing today, are the major one that I like to focus is desalinization, as we mentioned, and recycling wastewater in the agriculture sector. And that's something we have not talked so much because, as you know, agriculture is the major water source in the region. And this is the way Israel has been adapted to this reduction in water availability. Still, agriculture today in 2012 was 57% of the total water consumption in Israel, for which fresh water was only 40%. The rest was recycled wastewater or water from Shafdan that was used directly for irrigation. So this was one of the ways that Israel adopted by, instead of using fresh water for agriculture, using treated wastewater. So that sounds good. Well, wait a second. And then the way Israel used for drinking water sector, today, or 2012, about half of the water used in the domestic sector coming from desalinization. So Israel has been reduced their dependence on freshwater resources, because for domestic they're using man-made water, and for agriculture they're using recycled wastewater. But doing so, from scientific point of view, the good news that we don't have any water issues and only matter of distribution, policy, it's wrong. Because if the plant falling down from any reason, the desalinization stopped tomorrow because of, you name it, Israel facing the real issues. And with respect to, this is just numbers for desalinization, we can see the evolution of desalinization. Israel is the leading country in the world in producing desalted water. mainly from seawater desalinization. You see in the map the distribution, the different plants have been established. You see the numbers is rising to about 500 million cubic meter per year of production. This is a real tremendous achievement from technological point of view. However, there is a huge dependency on the ability to operate and to manage that in case of emergency. And in the Middle East, emergency is the second name. So this is kind of a dependence with respect to, and this is another value just showing the total desalinization of brackish versus seawater, and we see that we are near to the level that desalinization becoming even more than 50% of the water we use, or Israel used for drinking water in the domestic sector. And one of the major technological achievements was using, in Ashkelon desalinization plant, using a different high pH, low pH desalinization. This is a huge breakthrough in order to remove boron from seawater. Boron is an element that is not harming us for drinking water, but the plants are having elevated level of boron would hurt the plants. And one of the breakthrough technological achievement in the first one in Ashkelon, now is also in Hadera, was to remove boron from this desalted water by this alteration of high pH, low pH. In this technology, Israel is generating boron-free drinking water, which is important because those drinking water go back into the system by recycling wastewater, and you're able to use the treated wastewater for irrigation. Now, the bad news, this is in Haaretz from this morning, that there's a study in the Volcanic Center has shown that the celebration were too early. Because if you take saline water, which this is the source of groundwater in Israel, I'll show you in the map, and you use this as a drinking water, that's fine, or we can cope with the level with relatively high salinity, and use it for treatment. Treatment of wastewater does not remove salt. It removes organics from the wastewater. The salt go back to the system, salinize the soil and underlying groundwater, and eventually the fruit and agricultural product in Israel have higher salt content with respect to sodium than any other plants on earth. So the recycling thing, which is a great idea, has its impact on our ability, and there is a question whether this is sustainable into the future. Amar did my work. I don't need to talk about the Gaza Strip, the background. This is one of the most stressed areas in the world. A population of almost 2 million living in a very narrow strip. And the water quality in the Gaza Strip is extremely problematic. Water quality is exceeding even the Israeli drinking water standard. And our study before found that the most of the salinity derived from salt water coming from the Israeli side, natural occurring, flowing into the Gaza Strip, and we did it by a large operation of geochemical analysis, in addition to the man-made wastewater contamination coming from human activities overlying the Gaza Strip. We conducted a study that has shown that if you build a line of desalinization along the border between Israel and Gaza, not only you would take the salinity away from downstream Gaza Strip, but also you would produce a new water source for the people in Gaza. In this kind of a model, we actually say how technology can build trust and can build cooperation between Israelis and Palestinians in the Gaza Strip. So maybe it's kind of, again, we proposed this in a paper in early 2000. We are now 2014, and the same situation will just get worse with respect to the situation within the Gaza Strip. So lack of cooperation actually has led to ecological and social issues that we see every day. And finally, the West Bank, the issues of the West Bank, just go very quickly. It was mentioned the lack of equal distribution of water use between Israel and Palestinian in the West Bank. And the issues is that based on the Oslo Agreement, the Palestinians were allocated all the eastern part of the mountain aquifer. Well, if they would ask hydrogeologists or geochemists, they would tell them that this agreement is not sustainable because the water quality in the eastern aquifer is not suitable for consumption, and if you start to use it, the salinization will become even worse, and therefore you are getting all saline groundwater along the eastern part of the mountain aquifer, which meaning Jordan Valley and the eastern aquifer cannot be consumed into the future, even if you want to go ahead with this slow pool. In conclusion, my point is that water quality is a major water limiting factor in the Middle East. Climate change, which is here, is going to make things worse. We're just in the beginning of a process. It's vital to integrate scientific information into big pictures. We talked today about social issues, we talked about political issues, but without the ground scientific foundation, many of the solutions would not be sustainable. And again, because we talked the technology, desalinization should be part of any kind of agreement, any kind of a treaty between the parties, and perhaps into discussion about once we, as Amr said, once we have the water that we ought to have, then we can negotiate about we can buy more water. But we leave it for the next discussion. Thank you for your attention.
Okay, I will take a PowerPoint, and I'm an economist, so I'll speak a little quite fast. I was born in Israel, but I'll speak mostly about California, but I think it has a lot of lessons to Israel in general. Now, recently I was asked to have a study on what are the main achievements of the University of California extension over the last 100 years. It's 100-year-old, and we asked about 50 farm advisors and administrators and county directors, what was the biggest achievement of extension? And I didn't know, I expected IPM or labor. I was surprised. The answer was drip. And drip irrigation had a huge impact on California agriculture. And that's something that I really didn't know because I myself started my research working on drip the last 10 or 15 years. I haven't worked on it very much. So to some extent I came back for it because I said, "Look, if it's worth something, let's use it." Okay, so to some extent drip has been a big success. So let me tell you a little bit about what we learned about drip in California, what its implication, and also about some of the bigger issues that relate to technology from an economist perspective. When I started working on drip, there was a big debate between some scientists that said that there is no understanding how it works, so it cannot work, and people in the field that really were trying it. There was a person in San Diego, his name was Gustafson, that used some netafim drip from Mexico to demonstrate to farmers that it works, and that's the way it started. It has a lot of failures along the way. What my research showed is to try to develop an economic perspective why it worked and where it was working. And in drip throughout, there was one of these two camps. On one hand, people that wanted to require every Californian to have drip if he wanted or not. And the other camp scientists that said it wouldn't work, it's not sustainable, all the other things that people like to say about technology. And what really happened is that what we figured out that drip basically does two things. It basically replaces the soil and maintain water, so it really prevents a lot of loss of water. It improves water holding capacity, and it improves precision, so you really can you can apply where you want the water. So it will be much more effective when you have an even soil, when you have sandy soil, when you have heavy soil. It will be more effective to one crop versus another. And what really happened, that gradually the technology moved very slowly, but it moved exactly where it was supposed to move. What drip, for example, did, it allowed to grow avocados in California on the hills, it allowed to grow grapes on the hills, It's allowed to grow water in many parts of the desert. Now, over time, it improves. You have fertigation, you have precision. People now using computer to time drip. A lot of it came from Israel. And altogether, I think every year it saves something like about 2 or 3 million acre-feet in high-value crop. Now, you multiply it by about $400 or $500 per acre-feet, you speak about $1 billion a year. That's not bad. And this is a saving that you can get from one technology, and it's really improving. Now, over time, a lot of other things happen. People introduced a weather station, it's called Siemens. So it was a gradual process. In the beginning, I remember when I started it, I spoke with all the scientists, and there was a small group of people who said, "Good, these are the classes," and almost everyone else said why it doesn't work. But I think over time it was quite a success story. But what are the bigger implications? In California we have droughts. Now, I am 60, so I had 3 droughts. I had a big drought in 76, another big drought in 87 to 91, and now we have a drought now. 76 was a real disaster. And one of the things that happened after 76 is people start using drip. Before the drought in 76, no one even thought about it. Then, when people came from Mexico and they started selling drip, they tried something to save water. That was the beginning. The second shock of the drought, and that's when I think it can be a big player, was the drought of 87 to 1992. I have a study that's called How California Responded to the Drought. And basically, there are 3 things. Moving to sprinkler and drip among people that never believed in it before. Growing more groundwater. And then what happened, people introduced a water market. So to some extent, for me, technology is not only mechanical stuff or equipment, but also institutional arrangements. So we start having the water market. So really, it allowed us to deal with the drought in 1991. And today, even though we have a terrible one, we are much less hysterical. So to me, to some extent, technology holds a key for a lot of problems. But technology cannot go by itself. It has to go with the right institutional arrangement. And you have to take advantage of timing. Sometimes when you have a new technology, you have to dare. But at the same time, you need to have the incentive, you need to have the policies, and you need to have a foresight to know when to start the technology and when to move it. Now, 20 years ago, I tried to have a conference like this in the Middle East. And to me, water is one area where collaboration in the Middle East is possible. The big issue is land. Now, when it comes to salinization is a big solution, but it really tells you that the big resource problem that we will face is energy. And I think that is the biggest challenge. So to me, really, water is important, but we can deal with a lot of it. The big 2 challenges are land and energy.
So I've been watching the number of slides each person has as they put up their PowerPoint, if I could. And I want you to know that with the title slide, I only have 7. So it's designed to get through in pretty close to 5 minutes. Again, like everybody, thank you for the opportunity to participate in the panel, although I do have to say that when I found out that I was on the technology panel, I kind of pondered a little bit about what I would say, because I'm not really a technology person. I'm a policy management person and an economist by training. But what I thought I'd talk about is technology and cooperation, and talk about technology being part of the solution to water scarcity. But as I think at least one other speaker suggested, is that the engineering, the money, the technology, they really are not the barriers to solving some of the problems. Often the barriers are the political and the people elements of it, and getting to the solutions and getting them implemented. So I just want to add a little bit of a timeline here. The first image to your left is a cover of a newsletter that we put out from my water center in 2009 after we hosted a program called Arizona Israeli Palestinian Water Management and Policy Issues. We gave it AZIP as the nickname, and we had a nice logo. And we had a nice whole program, and 7 of the people who co-authored articles that in the book that emanated from it are actually in the audience here. And you see that face, that cracked face that many of you may be familiar with. That was the face of the need for conservation and addressing the water scarcity issues in Israel in the drought. And in the middle, I have a slide that Abraham Tenney, who's the director of desalination, and a friend, director of desalination for the Israel Water Authority, presented at a conference we had on desalination in Yuma, Arizona in 2011 about closing the gap. And look at what's listed: water saving and efficient use, water wells purification and aquifers quality improvement, increasing capacity of wastewater treatment and upgrading effluent quality, and then desalination. And those are the commonly seen lists. And then I've got the picture there on the right from WATEC 2013 that was held last October. And at that session that I was at, which mostly focused on the Israel water sector, but I was asked actually to speak about the transboundary issues of US and Mexico, there was more or less a celebration at that whole meeting about the water scarcity problem being gone in Israel. And Avner, I'm glad that I'm not the only person a bit worried in this room or unsettled about putting all the eggs almost for potable quality water in that one basket. And I've had a long discussion with another expert who doesn't see that, but I'm a little uncomfortable about that. And I am a little uncomfortable that we're forgetting those soft path solutions, the conservation solutions, others that are also important. But let me get to the point that I really wanted to talk about, which is challenges to cooperation. And I told Amar I'm going to make him a little unhappy because I am going to talk a little bit about the US-Mexico border here, because I think there are some lessons to be learned, and I'll be very specific about them. But on the left, those are 2 pictures that I took one day after the other in March of 2012, when I spent a month of my sabbatical in the Middle East. Now, why do I show you those pictures? What's unusual about that, or what to me struck me after I was kind of finished with my trip? And that is, most Israelis could not take that picture of the Palestinian Water Authority sign in Ramallah. And many times Palestinians have trouble getting into Israel for meetings and the like. And so if you're talking about cooperation, the people who have to cooperate have to be able to get together easily. And that's not always the case in the situation we're talking about today. Now, I also put up there a map of the Colorado River Basin to point to the relevance. We have our challenges here too. And Southern California, not Berkeley and not up here, is part of the Colorado River Basin, and that water is taken out to Los Angeles and San Diego and that whole region. But we have 7 states that share the Colorado River, 7 US states, the Republic of Mexico, and then also we have many indigenous tribes, Indian nations, who share the Colorado River. And they are sovereign when it comes to water management. So one should not just think that everything is so easy because you're even doing things within one country, and they're not. But I do want to talk just a couple of minutes about the International Boundary and Water Commission. And this is a binational commission at the US-Mexico border. Those are the pictures of the 2 commissioners. On your left, the Mexican commissioner and the US commissioner. They're each part of an agency that deals with water diplomatically across the border. And I want to suggest to you that when you think of this organization, you should eliminate your priors about who's the stronger party. It's not always the case that the country that you usually thought of as the richer country is leading the issues in these discussions. True, we have asymmetric governance structures and management structures for water, but they're very equal players in these international discussions on water issues. And in fact, Mexico requires anything water-related that is international at the border with the US to go through this commission. And on your lower right is a picture with the 2 commissioners visiting. They were guest lecturing at my class, giving a seminar They get together frequently. Sure, you have to get passports or whatever to cross the border, but they are constantly interacting with each other. So two particular examples I want to talk about, and that is a cooperative framework that was developed in 2009 that has guided aquifer assessment. Somebody talked earlier, at least one, about information and data. Somebody showed maps where the aquifer maps ended at the border. This program is addressed to jointly look and assess the aquifers. And again, I'm showing you pictures of workshops involving US and Mexican people. We worked hard just to get the cooperative framework adopted. It wasn't easy. But I want to tell you that once we got this, it took almost 2 years to get the framework adopted. The work has been guided by this to this very day, where we're near the finalization of 2 reports of aquifers at the Arizona-Sonora border, the 2 states north and south of the Mexican border. I also want to mention Minute 319, which was a historic agreement signed in November 2012. And it has to do with sharing Colorado River water in times of shortage and surplus. There hadn't been such an agreement between Mexico and the US, and also to address some very serious environmental issues of the Colorado River Delta. And in fact, I think a lot of people would have questioned whether or not this agreement could have been signed, but the agreement itself is an outgrowth of a natural disaster, the earthquake of April 4th, 2010. So what I want to suggest to you is that there are drivers to cooperation, and what I also want to suggest to you is that the structure of having a commission that actually has people empowered to make decisions under a treaty. The overlying treaty is the 1944 treaty with the US and Mexico on the Colorado River, but these 2 individuals are empowered to make agreements, and each of these agreements is called a minute. That's where that comes from. So maybe some change in thinking about, well, maybe this Joint Water Commission isn't working so well, and maybe we need to think about some other institutional arrangement while we're even waiting for all these other difficult peace negotiations to go on. There are models to look at that I think can serve the region well. Finally, my last slide. This is a picture of the book that we edited after the workshop we held in 2009. I've got some bookmarks on it. I don't get any money from the sales of the book, so I'm not here to peddle the book to line my pocket, but we have a lot of good papers in there. On the left is some snapshots of a video that was shown on Israeli news. It was shown in February 2013, but it was from a visit that I led. We called it the Israel Water Management Program in November 2012, where I took over about 9 other water experts, including the woman shown on the lower picture, who's an official with our US Bureau of Reclamation, took a mayor of one of our towns in Arizona, who's the president of the Arizona League of Cities and Towns, and several others. And if I had the pointer, there he is. There's our friend Clyde right there. We were right at the border with the West Bank and seeing some of the examples of some of the pollution and issues there. But I want to end with just talking about these 2 pictures on the bottom. And I took my group to this. This is the aquifer area where wastewater is treated through, there are placards there that says emergency solution for the sewage of the Nava, from the Nava stream, and it's with Tokaram and the aquifer region. And on the right is the aeration ponds of after secondary treatment of effluent that emanates from the West Bank, and you see ducks there, right? And then they use that water for tree irrigation. And on the left, almost adjacent to it, I mean they're right there, you just walk from one to the other, is just raw sewage that's foamy, there are no ducts. And I would say there's technology to address this, and it's all those other issues of the willingness to get together to do that. And I personally, I will go back to end my comments with Musa's comments last night. Not all of you were at dinner, but there are certain things that kind of change your perspective on life or about things as you experience them. And some of my participants in my group trip about water management said the trip changed their lives and their perspectives. But I gotta say, seeing those two ponds right next to each other and seeing the damage being done to aquifers, it really changed my perspective. And I think we can do better than that. Thank you.
I want to thank all the panelists and ask that everybody stay at the table. I'm going to ask a brief question and then we're going to throw it up to everybody. But I do want to bring us back to the headline for this session, which is Technology and Innovation, Changing the Political and Environmental Calculus. Thank you very much, because that's the most needed. So we've heard several different perspectives here. We've heard that perhaps for issues of water shortage, conservation and drip irrigation is maybe a panacea, that we're getting this new bonus of desalinized water, but other voices saying let's not be excessively optimistic, or let's recognize that these plants can falter or they can be sabotaged, and then water resources may not look quite as good as they do. We've heard that it's maybe the problem is not technology at all, but it's maybe governance. We had the comment in the earlier session from Sam, who said we're still missing a fundamental component, which is issues of sovereignty, basic issues that haven't been negotiated and have not been resolved with justice. So I guess what I want to ask the panel members are, do we have a situation now which is fundamentally different than it was 10 or 15 years ago because of technology? Is it a game changer? To what extent have we seen a change in the political calculus? And I want, if you would mind starting off, because you're first on the line. I think it's also, the big question is, because the Palestinian situation is so very different, I'd like to hear your view on that.
Thank you. First, in the West Bank, since 15 years, the infrastructure is developed well. For 15 years, we don't have a lot of money, many water network. Now, the network are available, but water is not available. I give you an example. For example, the consumption of Hebrew is per day 45,000 cubic meter, and they receive only 17,000 cubic meter. And this is the case that now the fund agencies, they fund a lot of money, what we call it water infrastructure, but on the other hand, water is not available. I believe that desalination is the solution. It's the only solution for the region, but we have to clarify before what we call it the sovereignty. And I want to add, I said in my presentation, tension and transboundary and trend, but I can add two things also action together to solve the problem, and also technology. So,
do you have another panelist who wants to deal with that question before I throw it to the audience? Please.
So there is a huge differential between how Israel and the Palestinians see the changes, and the game changer definitely for the Israelis, desalinization, which now we talk about 80% of the drinking water in Israel because of man-made water from the Mediterranean Sea. It's definitely a game changer, and some farmers, I think you mentioned, that are already thinking about using desalted water for farming, which is 10 years ago, if you think about it, would be kind of ridiculous given the costs and all that. So the game changer was the ability to generate water with about 55, 60 cents, which again, that was one of the breakthrough to ability to do desalinization at that cost. Now, given that we're talking about this disproportional situation that communities in Israel have not worry about the drought because they're well adapted to that, versus communities in Hebron that don't have water in the tap and have to go for the water truck, this creates a tension that needs to be resolved following this breakthrough, and I think we're not there yet.
David, please.
I think that 50 cents per cubic meter or whatever sound cheap or whatever, but actually for most farmers in the world, including California, they cannot use the water. So it's really a solution for open water use, which means that you assume that all the Israelis and Palestinians will be a computer programmer and Uberite. And if you have money, you can solve the problem. So to me, like I said before, to me the water problem is solvable, especially when you look at the area where you have other problems. And there are a lot of lessons that combining institutions and technology you can solve a lot of problems. But to some extent, if you ask me if we went forward or backward, as someone that was active in the water area 20 years ago, I feel that we are in a much worse situation. We have to be honest about it. I think that 20 years ago there was more cooperation between Israelis and Palestinians. There were a lot of companies that were starting together, and now we start to rebuild it before. So the challenge is to build the momentum and to move forward.
I just have two comments briefly before we throw it to questions. The first is just an interesting fact that I was stuck in a chapter of a book I'm writing, that today in Israel there are 24,000 people who define that they're self-employed farmers in Israel. And there's 26,000 foreign workers who work on farms, just in terms of how much is urban and how much is not. The other one was just an interesting anecdote. When Israel first built its desalination plant in Ashkelon, it wasn't clear what to do with all the water because the network, the physical infrastructure to pipe the water to the whole country was not in place. And so after providing water to Ashkelon and Beersheba in the south, they had a lot left over, but wasn't sure what to do with it. And they said, oh, let's give it to the farmers in the Negev. All these years they've had to deal with brackish and saline waters. Let's give them champagne. And what happened right away was that the crops of these farmers, much to their astonishment, started to wilt and the yields dropped. And the reason was the desalinated water was too clean. It didn't have some of the minerals that had come from the original national water carrier. So now at the desalination plants, they add some certain basic minerals to make it acceptable for agriculture. And it is seen, at least in surveys in Australia and in Israel, that not all crops, but there are crops which can meet that high price and still make a profit. Let's have some questions. We got a little. She certainly deserves the question.
So this is a question to Nati. So I'm interested in the way, as a private company, as a private business, as you say, I don't have the language to even talk in terms of market, but how does these packages in which the drip technology with promoting a vision of agriculture, for example, in Gaza and in those poor communities, how does this work? Who are those NGOs you're talking about? What's the package? Is this an initiative of Palestinians in Gaza? Who's asking for it? How does it?
It's a combination. The specific project in Gaza was initiated by USA, and the financing came from USA, and there was an NGO involved that was kind of the go-between. They provided the training and the initial maintenance work and so on, and we did the design and supplied the system, and we trained the trainers. And this is how we work with poor farmers. We are starting now a similar project in Kenya, where we plan to approach 2,000 Kenyan poor farmers. And again, it's a partnership between USAID, local banks that will do the microfinancing, and our representative over there. So the package of working with smallholders, it cannot work. It does sometimes, but in a very small scale, as a very simple, basic business transaction between Netafim and the customer. Because let's say that we are talking about $200 per family, still it is a lot of money for them. So someone has to organize them, to do the financing, to build the training, and it should be an NGO, local government, international financing organization, and then the farmer himself, and us all through our local representative.
Great. Please, I'm supposed to remind people that we're looking for questions, and only the briefest of comments.
I have what might be considered a kind of utopian question, but it's one that connects the third session with the fourth session.
Where else but Berkeley would you want to ask about utopians?
And there was a tease that Alon gave about the conversation between Jordan and Israel about the necessity for water and he didn't give an answer whether what Israel replied about whether we're able to supply water to starving people. The fact is that there are many starving people in Syria and in Lebanon, and whether this kind of thing could be looked at in a broader term. And the other question is, who owns the Mediterranean? There's all of that water. Does it belong to Israel, or it's the technology that Israel does in order to create the desalinization that allows them to take the water out of one place and give it to another place?
Would somebody like to field that question? I would only say that Israel did sign an agreement at the World Bank in December with Jordan and Palestine. And in terms of what David said, it's the first agreement in a very long time there's been, and it was for the first time they were going to already bring Jordan a fair chunk of water based on the excess water through the pipeline there. I don't know what the answer was because I heard the presentation from the Minister of Environment of Jordan, not the Minister of Water of Jordan. And with regard to the Mediterranean, I would think that water inside Israel's territorial waters are Israel's property, just like, all the way through the economic zone. I don't think there's any international treaty which prevents a nation from using it. Musa, you're up.
Yeah. So the fact that there's a good desalination plants, will Israel be okay allowing the Palestinians to pump more water and the Israelis to reduce pumping water from the mountain aquifer, for example? And will this be okay with the Palestinians?
I would like to restate his question, but I'm not going to answer it. I think, as I understood Musa's question, is with the greater availability of drinking water from desalination plants, would that then result in Israel allowing more water to be pumped from the mountain aquifer by Palestinians for Palestinian use? That's, I think, what I understood your question to be. Is that right?
And for the Palestinians, that this is okay with them.
Okay. Well, I can't answer it.
It would be great if the Israelis give us a permission to drill wells and to take water from the mountain aquifer. Why not? But the Israelis offered us what we call it desalinating water, not water from the mountain aquifer, to sell us the water that they produce it in the coastal area. Because if you calculate the amount of water produced in Israel, it will be about 500 million cubic meter. In addition to the local water resources, it will be, the market is either for Jordan or for the Palestinians.
Alon, can I just add something here about my region of where I live? I live in Tucson, Arizona, and we're reliant on Colorado River water delivered through the Central Arizona Project. I happen to be an elected member of the board of the Central Arizona Project, and we are in the target of climate change impacts. The Colorado River basins in 14th year of drought, 14th or 15th year, and there's a high probability, 50% or so, that a shortage could be declared on the Colorado River in about 2017. The first impact to a shortage on the Colorado River water is to Central Arizona, and the number one impact within Central Arizona is to agriculture. And so, although we call the Colorado River renewable supply, it may not be all that renewable in periods of time, especially if this drought continues. Groundwater is an insurance source of water. We have some deep aquifers and very good quality aquifers, and these agricultural entities will go back on the pump if they can't get the Colorado River water. So not to get into the middle of Israeli-Palestinian issues here, but I would think Israel wants to keep some groundwater for some insurance. I don't know that, but we certainly do in Arizona.
David, a brief response, we'll go to the next question.
Several years ago, before it all started, a colleague of mine wrote a paper about this idea. Economists can think about before it happened because it was quite likely that it will happen. And the idea was you have 500 million cubic meter of desalinated water, what will happen? So the solution was that the supply of water increased, more water is being used, some water is being used by Gaza and some water is being used by Hebron. So to some extent, from an efficient perspective, and I think that in this regard economics is very useful. What happens if the world will be run by sane people rather than by crazy people? From an efficient perspective, obviously if you have more water, then everyone that can do something with the water. So if you want to grow grapes in Hebron and you can pay for it, you do it. So to me the big issue is, should be an economic issue, shouldn't be a political issue. And I think all the calculation of the aquifer will change and should change with this thing, because you can reach out aquifer.
Thanks very much. We're going to do 3 questions now.
Just a comment on that. Just to Musa's question. So I think we have, if thinking about a bigger picture in terms of changing game playing, there's some ideas that if we have sustainable use of desalination and can generate more, we can give up the Sea of Galilee, Lake Kinneret, and stop then open the dam of the Sea of Galilee, renew the Jordan River, and perhaps save the Dead Sea instead of this Red Dead Sea project, which if you talk about any hydrologists would think it's the most stupid idea. So there are several ways to see it in a much larger scale by saving the Jordan River, saving the Dead Sea from desiccation, which we haven't discussed this here, and using the water that Israel uses for about 400 million cubic meter a year, generate more desalted water. In this kind of game-changer plan, Palestinians should have a large chunk of the Jordan River, which they cannot have, and perhaps they don't want to have given the quality of the Jordan River. But now it's going to be a freshwater again. That could be some compensation, and therefore they will have natural water rather than desalination. But this will be the way to going back.
So if we're talking about the impact of water technology on the kinds of calculus that we're talking, both about between countries and individuals, I'm wondering if you all could comment on how it might help us to look at other cases of technological ramping up. So for instance, in agriculture, we've had a long time to look at green revolution efforts and all these kinds of things. And a lot of what we see is as agriculture has become more sort of tech-centered, we see exacerbation of differences in economic standards and socioeconomic standards, as those who have the most capital can take the most advantage and buffer the tech failures, and those who are maybe less capital intensive to begin with sort of stay less capital intensive. So I'm wondering if you can comment on that.
Again, I'm not sure that I'm answering exactly what you wanted, but for example, I think that as a business, and we're talking about agriculture, we cannot ignore the poor farmers because of magnitude. There are 500 million smallholder farmers in the world. They produce 80% of the food in the developing countries. So I think that as a business, we cannot ignore it. We must find a way to approach them and to do business with them. And the way is like what I said earlier, partnerships, microfinancing, and so on. So in the future, I see them as the new frontier for agriculture, bringing technology to them. And there are other advantages to that, like what I said earlier, capacity building, keeping young people in agriculture, attracting them with innovation and technology and so on. So yes, I see advancement in agriculture in the next generations.
Okay, actually, my research is on technology, and sometimes what I say, generally speaking, if you look at the technology actually really helped a lot of poor people. Generally speaking, everyone has a cell phone. This is something that you have 5 billion of them around the world. Now, so there are big differences in earnings between people. There are big income gap in terms of earning, but there aren't. But in terms of access to technology, it's improved. Now, in agriculture, we have a big controversy about GMO, but at least what our research has shown that already it reduced the price significantly, and 90% of the farmers in India adopted it. So to some extent, there are a lot of technologies. If you start to look at them, some are affordable and some are not. Like drip was something that was considered relatively capital intensive and inaccessible. That's the reason that it took about 40 years to be adopted on a large scale, and it became cheaper and cheaper, and now they adopted to the needs of other farmers. Other technology, like a new seed varieties, green revolution with all the problems, they increase yield. They didn't make people rich because this is a simple separate problem. So some technologies can spread very fast, and other technologies spread very slow. The question how much it requires in terms of knowledge, in terms of capital, and the overall thing, as long as we have people that do science, and that's one thing that good about the university, all the time has come with a big solution. The thing that I worry is not so much the accessibility or availability of technology is the big difference in earning, and we start having a big gap between people that have education and can be very well and people without it, and that to me is the biggest challenge of development today.
What we see here right now is a celebration of technological optimism, as we spoke before. You know, water access, we can be distributed, solve many things, but it's not. Technology doesn't move that easily, right? We need an energy structure. We need to differentiate the waters. What we have here is actually maybe just, I want your reaction, another boundary between those who have the technology to do that and the energy. So Israel now, it's not even in the playing field. Actually, Israel now has the water resources and desalination technology. And what makes you so positive that this will equal the game field?
I have to confess, I am optimistic, but if I see what happened with Nerfing and drip irrigation in the last 50 years, next year we are going to celebrate 50 years for the introduction of drip irrigation. I see how it moved from cherry tomatoes and strawberries to cassava, maize, and sugar cane, and today to rice, and we have excellent results with rice, and cellular phones are excellent examples. So yes, I see in few years rice growers in the Philippines using cell phones to get the training and get excellent yields on rice growing in 2 seasons a year, the dry season and the wet season, whereas this year they're using only during the wet season without the cellular phones. Sorry.
I've been exposed to many, I'm an irrigation specialist at UC Davis. I've been exposed to many examples in Europe, Africa, and the Middle East where technology is available but is now uptaken by the agricultural sector. Now, the question is, don't you think that the big achievement of extension is extension itself? Enabling the condition for, farmers and mutual trust between technology and farmers.
But to me, the marketing department is not. I think if you look at the drip irrigation in California, there were about 4 or 5 sources of success. The researchers at the universities, Metafim, extension, a lot of private universities, and all the farmers that were teaching one another. You basically, technology transfer is basically, it's a family enterprise, and you need that everyone is going together. And a lot of time, extension was the grease of the system. Without extension, things wouldn't have moved around. Extension was the gossiper, extension was the people that introduced one another, extension was the conveyor of events, so extension is very, very important. I wish that we can speak, I don't know about what's going on in Israel and Palestine, but some sort of effective extension can be a very good mechanism to bring peace.
Okay. So my question is regarding desalination and the talk of Israel going to 80% desalinated water for potable water. There was talk about Gaza, about Jordan. Egypt would be next in line. I presume that all of the salt slurry is being dumped back into the Mediterranean. And is anybody looking at what damage, how long it takes with so many people extracting the fresh water out of the Mediterranean before that begins to look like the Dead Sea?
Extraction doesn't seem to be a problem at all. There are some questions about the discharge. The radius, at least in the most recent studies that come out, are about 500 meters radius around the site. Some people claim it's a boom because it has high iron, which makes it sort of a fishery in the Mediterranean. My own view is that we have literally hundreds of desal facilities going along in line with in the Mediterranean. Nobody has a clear sense of the cumulative impact. But right now, I haven't seen anything on the marine environment which suggests that we're heading for disaster, but it's a very, very early stage in the experiment.
Yeah, I second that. I mean, what we're doing, there are 2 issues. One is the salt. It's recycling of the sea salt back to the back to the sea, and the dilution factor, even if we have 10 times, 100 times more desalination in Israel, is negligible. And the real issue is the organic matter that we put for descaling into reverse osmosis desalination, and that could be an issue, although many studies have not seen any effect on the ecological system.
Question of A and B, A to Dr. Mer'i and B to Mr. Avner. Let's say you have been talking about water tension, and we are intervening a lot in the southern part of the West Bank, southeast of Hebron, in the area of Yatta, in the area of Samoa, and so on, where people are living really on 20 liters per capita per day. So I guess that a lot of water cost tension is happening also there. At the same time, in the nearby eastern aquifer, or let's say water in the nearby eastern aquifer, is exploited to about 50%. So 50% of water in this aquifer is not at all exploited. Do you think that exploitation of further water, extraction of further water from this aquifer would alleviate this water cost tension? And to Mr. Avner, do you think that further extraction of water from the eastern aquifer would damage the quality of the aquifer, of the water aquifer itself?
The USA drilled to the east of Hebron about 5 wells during the last 10 years. And they predict to produce about 8 million cubic meter a year. And nowadays they produce less than 1 billion cubic meter. The problem in this case is related to they did not identify the real recharge area. And according to our analysis, we find out that water is old, it's about 60 years old. So it's relatively, it needs a lot of time to travel through the mountain aquifer to that place. One of the suggestions to solve the problem, not in Hebron, Bethlehem area, to salinate or to use the brackish water in Ain al-Fashha. Ain al-Fashha is one of the major springs in the Dead Sea, close to the Dead Sea, produced about between 50 and 80 million cubic meter. And still there is negotiation between the Palestinians and the Israelis since now, I think, 20 years, about how to use this water. And on the other hand, this spring located minus 400 meters below the sea level. And Hebron located about 800 meters, so it's not possible to use this water to pump it up. It's better to have water from Mackerel than to pump water from that area. So it's the question of the location and where we can use this water.
Ladies and gentlemen, first of all, I want to thank our panelists for their wonderful contributions.